Hello everyone. Here's how you can reduce uncertainty in AI projects, even if you're new to the field. We're going to reveal 5 game-changing strategies that will transform your approach to AI implementation. Whether you're a seasoned data scientist or just a curious business leader, these insights will help you navigate the complex world of artificial intelligence with confidence. Get ready to unlock the secrets of what we're calling successful AI projects and leave uncertainty in the dust. Let's dive in. Today, we're tackling a topic that's been keeping many of you up at night. And these are the messages and these are the conversations we're having with clients. Uncertainty in projects. Whether you're just dipping your toes into the AI waters or you're already swimming in the deep end, uncertainty can feel like a riptide threatening to pull you under. We've got 5 life-saving strategies that will help you stay afloat and even ride the waves of AI success. And we all know there's some serious waves around. Before we jump into our strategies, let's quickly define what we mean by uncertainty in AI projects. It's that nagging feeling that things might go wrong, that your AI might not perform as you expected, or that you're investing resources, money, people, time, etc., without a clear path to success. It can stem from data issues, complex problem spaces, or even ethical concerns. But here's the good news. Uncertainty doesn't have to be your project's downfall. In fact, with the right approach, you can turn it into your competitive advantage. Today, we're going to dive into these multiple strategies, and there's only 5 of them. So let's go straight into it. The first one is clear problem definition. Hey, Dimitri, welcome. We're back together again after your travels and to see all the clients and so on. So you must have been pretty hectically busy. I know things are just rapidly expanding. The conversations are almost heating up, and we're having people come up with multiple challenges. But today we're gonna focus on 5 really specific ones. And let's go straight into the first one, which is clear problem definition.
Yes, that's actually one of the biggest issues in uncertainty, in reducing the uncertainty in pretty much any type of the project, and especially in AI, because artificial intelligence is in general, to some extent, unknown animals, right? And if you put, I guess, not bad practices on top of this, unknown animal, you have all kind of issues, all kind of unexpected events, triggers, and so on, so on. And that's actually, from our experience, it's not that rare when people don't pay much attention to the first stages of the project, I guess, problem definitions, requirement definitions. Very frequently, a lot of people tend to jump immediately into the solution, into the technical discussion, and so on, so on. And actually, a lot of effort that we put on, they are related to kind of to pause the process and to deliver this message. Hey guys, let's just pause for a second and let's make a couple steps back and take a look at the big picture. What exactly we are trying to do? Why are we trying to do it? Who is going to be end user? What kind of problem are we going to solve to this end user? And the beauty of such questions is not just kind of following best practices because it's the best practices. It's actually, there is a reason why they're called best practices after all. That actually helps to align everybody and to make sure that every single person who participates in the project development is on the same page. Because even to the developer, even to the engineer, if you don't explain why he performs these specific tasks, he can get very creative and he can get it in the way how he thinks this specific technical task should be done. And it's not always the right way to do it. And by right way, by the way, you need to be very careful, because right way is not just technically right way. Right way is how quickly, how deeply, which specific features you need to do, within which time frame you want to do. Maybe this feature needs to be done tomorrow because there is a very critical contract is on the line, and this contract needs to be signed. And without this specific feature, this contract just won't go through. Or maybe this feature is actually very fundamental, and it's trying to satisfy some kind of strategic goal for the next year, and you need to create something, I don't know, for example, I don't know, scalable, high performance. And then, yes, you have more time. You have actually 6 months. You probably have some more people working on this feature, and you need to approach to this problem more fundamentally than just, hey, let's just close this small issue with the performance, I don't know, quickly scale up servers or do something quick solution. And answering and actually clearly defining why you need to do something, for what purpose, for whom, what kind of problem you want to solve, and involving everybody in this discussion actually helps meet the business needs. Remember, we are meeting business needs, not technical needs when we work on the project. So I guess that's all about clear problem definition.
Yeah, and I think, yeah, and I really like what you're saying there, because defining the problem clearly, and it's not just a technical. Well, it probably starts with a business problem, and you try and solve it with a technical thing. But one of the questions I like to ask is sort of like the success metrics. Sort of, what does success look like to you? So let's assume we've achieved this particular, let's say, problem. We've solved this problem. What does success look like to you? What does it look like at the end, so we can work backwards? I don't know if you must have heard of there's a you know, when you die, there's a post-mortem. In other words, after death.
Well, actually,
there's a
yeah.
Yeah, what we want to do is we want to do a pre-mortem before the project comes to an end because of bad planning.
Well, I actually would like to shift your timeline for success a little bit earlier in the project life cycle, and frankly, to put it at the almost at the beginning of the project. And the success metric from this standpoint, from this timeline standpoint, sounds like this. Well, I did try explaining to our clients multiple ways what's the best way to approach the project, to make sure that to explain what is uncertainty, what is ambiguity, that this is actually a natural way how it works for any project, what needs to be done to tackle it, what's the end goal, how it progresses. And actually, the most successful way to explain it, and that's actually very well taken, is to explain it within the cone of uncertainty. So that's actually is relatively known term, but it's not widely used by some reason. And once I show this cone of uncertainty to any person, technical, non-technical, doesn't really matter, everybody immediately understands it, and everybody immediately are on the same page with what I'm trying to explain to them. Oh, now I see it. So at the beginning of the project, I have a very wide range of uncertainty. And I mean, you just need to explain. People are smart, right? After all, I mean, they're not stupid. And you just need to push this uncertainty at the first couple stages of the project lifecycle. You need to just to maximize this push, just to keep this uncertainty as narrow as possible. And it will exist through the entire project execution. It's just gonna be smaller with every step, and you just need to do some activity, some efforts to keep it squeezed as much as possible. Obviously, well, I mean, you're gonna be limited by time frame, by budget, and everything else. But there are solutions to squeeze this uncertainty. And again, it is extremely important to understand that you need to squeeze it literally before you even start talking how you're gonna do this, and actually conversation about what are you trying to achieve, for whom, what kind of problem you're trying to resolve. Those conversations do squeeze this cone of uncertainty significantly at the beginning stages of the project execution.
Yeah,
So,
and maybe
yeah.
if I could add one other bit of uncertainty, I think it's really good to have these frameworks and that. But after a conversation yesterday I had with somebody where they were talking about the change management elements of these uncertainties, and if you think about the people that will be physically using or being exposed to AI are the people on the ground often. And we had these conversations about how it affects different people.
Yes.
But there's also fear, and there's uncertainty in fear, as in, if we implement these things, these AI things, potentially, whatever the solution is, potentially I could be losing my job. There's an uncertainty that's not necessarily related to the business, but it could be related to the individual that needs to be doing the implementation. Is there enough data? Data could be a complete mess as well. So there's a lot of things that's uncertain at the beginning of a project that you've got to try and identify as early as possible, just like you were saying there, understand that kind of uncertainty and understand what those elements are so you can address them as quick as possible.
Well, obviously, the data is a crucial part, and I think I would put it in the top list of the uncertainty in AI project. And the problem with data that it might not be usable, even so you have historical data, and I don't know if you want to use it for machine learning, for example. It looks good, it has timestamps, it has some metrics, it has some information, timelines, and so on. But by some reason, I don't know, not consistent, some fluctuations unknown, some deviations, so many other things that can affect the quality of the data, and it's just not usable. And actually, for example, in machine learning, there is a very well, again, industry best practice process that not exactly takes this into the account by some reason. I don't know why. So generally speaking, it is recommended to do business analysis first. I mean, so what kind of problem you want to solve, right? And the next step is actually gathering data, cleaning it up, preparing it for the looking at the data in order to decide what kind of model you're going to use to process the data, and so on. And sometimes, especially small players in the market, they cannot afford to lose money. They literally count every dollar, right? And for these clients, we actually developed, I guess, our own approach to this problem. We call it early circuit breaker approach. Basically, what we do, we don't do business analysis. Well, of course, there is a quick conversation about what needs to be achieved and everything else. I mean, after all, you do need to understand what exactly you're trying to do. But it's not a classical deep business analysis with a classical problem definition and so on. It just, well, I mean, most of the cases, it's a more or less typical issue, especially like in the healthcare industry or in the real estate. We can, very frequently, we can deduce what specifically clients want to do with this data using machine learning without even talking to the clients, which is clarifying. And what we do, we actually run a dirty model implementation. So this model, we know it's not going to produce a great results because we make it quick and dirty, right? I mean, that's kind of the whole definition of this. But what it allows us to do is, on the early stages, to determine if this data, well, first of all, more or less usable, more or less, and more likely, right? And actually, we're very clear about this. Hey, guys, because it's a shortcut way, and there is some, unfortunately, we are increasing some uncertainty in this, but well, I mean, it is what it is. More likely is proper data, and more likely you will have some business insights based on this data. And sometimes it's actually we when you run machine learning project, those business insights, along with expected business insight, there are some unknown business insights, some unknown conclusions that these machine learning models produce, and actually a very fascinating thing by itself. And at this early stage, as I said, clients can say, well, my data is actually more or less usable, more likely is usable, and my data more likely will produce this business insight, and that satisfies me. Or it can say, no, it's totally garbage. We need to just to rethink, and you need to start gathering your data with a new way, re-implement your data gathering algorithm, whatever it is. And we terminate this project, or actually we place on hold this machine learning project. And that saves them money, again, for the clients who counts every dollar. But again, that's to some extent contradicts with a classical, more proper approach when you do business analysis first, data gathering and data cleaning second, data model applying second. Well, I mean, third, I'm sorry. So it's just different ways to
different ways.
Yeah.
And it's almost like what you're doing there is doing a bit of a proof of concept to a certain extent, because you're cutting down potentially a lot of the time. I mean, there's always this time elapse, and people have high expectations in the beginning. If this thing takes too long to deliver some kind of tangible or visible result, if you don't take a few shorter steps to get some initial output, then it starts looking like, oh, this is going to take too long. We're never going to see a result, etc. And definitely, I like that shorter cut approach. Let's see what it is that we need to do, and then sort of deliver something. But there's also data, which is a good thing. If you do that quicker model, is to see what you got available to run those things, and then to see what you can pre-process. Because I had a conversation earlier, or end of last week, where one of the companies, they have a lot of paper data from the past. So they have processing, let's say shipping documents, etc., a lot of printed paper that's not really electronic or in a digital format. Okay. So the processing could be, they are scanning these things in, becomes an OCR process, is a mini pre-project, if you like, in order to then extract really good outcomes from an AI perspective, or from a data cleanse perspective. And now you can normalize your data, remove any outliers, remove any things that have got missing values, for instance, and really get a good, let's say, a sense of certainty in this uncertain model we're trying to create.
Yeah, that's true. By the way, data, I guess clear data, or verifying the data quality, that's actually one of the ways to, I'm not sure if convince is the right word, but to show some clients usefulness of the artificial intelligence. So for example, we have one of the clients, and he is very conservative. So basically, no, AI doesn't work. It's produced random results. I want a very specific and very well-defined algorithm, and so on, so on. And he actually recently had a pretty serious problem, because one of the steps in his process involves a lot of human activity, and it's a very, very vague, very tiresome, very repetitive, a lot of data gathering, a lot of data processing, and you just cannot put it algorithmically, and you cannot just do this. And I mean, once he had this specific problem, well, obviously we asked him, do you want to kind of tackle this problem? I mean, it's not the first time when you have this. He finally gave up, and it actually looks pretty good right now. So we immediately reduce a huge, like literally not of the problem at the beginning of one of his major processes with his clients. So that's very, and again, that's good data that exists and that can be used for AI. But I mean, it's kind of, for us, we know we already see some data. It's like, oh yes, I mean, you definitely have this data. You got to have this data. We know that you have this data. Let's use this data for your purposes. So
There's at least a minimum requirement. So I mean, we've covered strategy one, which is really the clear problem definition, defining that problem properly. We've now done we've spoken about strategy two, which is a lot more to do with sort of data and the idea that sort of the garbage in, garbage out concept that we've said for years and years. It's still the same thing. Make sure that you can be certain with the quality and the quantity of data, and also that you're removing any missing data, outliers, etc., and making sure that you normalize the data into a certain extent, so that you're not sitting with sporadic data, so really good quality now and then. There could be gaps in terms of timelines or gaps in terms of certain transactions, etc. But if we start looking at now, we're going into the third sort of strategy, and I think you touched on that already to a certain extent, because you've got iterative development and testing. So what we want to try to do is say, think about AI and automation and cleansing of data and all these things, and also obviously identifying what it is we're trying to achieve. Think about the iterative development testing, and I think you've got some really good ideas around that, because what we're trying to avoid is a sort of big bang approach, like AI must go everywhere. We can't do that. We have to have probably more of an agile type of iterative approach.
That is true, and that's actually can be applied in general in implementation one model, one specific case, and actually applying multiple models all over the processes. So it is strongly recommended to do the iterative development, because well, I mean, there are multiple, I guess, factors that forces us to approach iterative development. I mean, in general, but I mean, specifically in artificial intelligence. Well, first of all, obviously adaptation. So when you work with someone who didn't do anything with artificial intelligence, covering multiple workflow, optimizing multiple workflow, or creating something else in multiple areas of the project can actually overwhelm. And it's actually a new concept, a new approach, a new way of thinking about your data, about how it works, and so on, so on. And actually, there is another twist. If you start working through this gradually, the client or the people who actually participate in this activity, they start to understand it more properly, more deeply. And as you approach next stage, people start helping it. People start seeing it differently, presenting it differently, and actually participating it more engagedly, more engaged in this process. So it's a whole spectrum of the benefits coming from this approach. And as for developing a regular model, well, unfortunately, I don't know. It's some kind of a misconception about machine learning. People think that, hey, you just create this machine learning model and it just works. Well, to be frank, sometimes it does, but in many cases, you do need at least to look at it, because the data changes. The value of the data changes. You have maybe some new deviations, and not just artificial deviations, but actually something affected the data that model is fed, and you do need to retrain it, or you actually need to apply a new model because the data just became more complex than it was before. And this gradual approach and reviewing the model is an essential piece in making sure that it's working. It's the same like with the security. You don't just build some security system around your infrastructure and you just forget about it. No, right? Because I mean, there are new threats, there are new applications, there are new frameworks, there are new requirements for the security, and you do it at least during some, I don't know, monthly, quarterly, annually. I mean, it depends on your processes, security level, and so on, so on. So same with artificial intelligence. You do need to review it monthly, quarterly, annually, depending on the project, on the complexity of your data, and many other factors. So it's as I said, iterative in many stages. But what I wanted to say actually for this podcast, connecting number one, start with a clear problem definition, and connecting number three, use iterative development and testing. That's actually, I guess, we will reiterate again. Very frequently, people jump to the iterative development and testing, thinking that this is a solution, this will solve all the problems, without starting with a clear problem definition. No. Agile didn't replace waterfall, guys. Agile improved waterfalls. We still have those small waterfalls during each interaction, guys. We need to step back. We need to define what we're doing, and we need to implement it. We cannot just jump in the middle and think that it will work.
We still got to have that longer term picture. What are we working towards? Because you're just going to constantly spin your wheels. Developing becomes crazy.
Yeah, we don't spend 5 months anymore on definition of the requirements. Yes, I get it, but you still need to spend some time in defining your requirements.
So I want to maybe just tidy up this point 3, because strategy number 3 is about this iterative development and testing. But there's a rule of thumb that I think is starting to emerge, and that's test early, test often. And it's don't wait until you have the perfect model to start testing. It's regular testing helps identify sort of issues early, and they're cheaper to fix as well if you get them early, and then gradually increase your complexity. So that's going towards your waterfall. So iterative, test early, test often, make the changes early, but you're still working towards that bigger picture. I really like the way you've brought the two together. Or else it can feel like the two contradict each other, but they don't really. You have to have a big plan, but you also have to have little plans, like smaller regular tests. And it does reduce the uncertainty if you can course correct. If you think about a plane, I think the pilots apparently do how many adjustments during a long flight, because the plane does shift its trajectory. It doesn't sit on a perfect path, so you have to always be course correcting as you go. So that's really good. So let's go into strategy number 4. I mean, we got evaluation metrics, and what we're trying to do here is create robust evaluation metrics that we can really understand of what makes something perform well in a lab environment versus the real world. Is it going to work in the real world?
That's true. Well, actually, there are 2 types of metrics, and you actually need to have both of them. So with the machine learning and with the large language models, there are, how I would call them, scientific metrics that actually very specific for the artificial intelligence from the science standpoint about the efficiency of the models. And obviously those metrics need to be tracked, and they need to be met, because if those metrics are not within the reasonable range, it means that your model, regardless of your business metrics, is a total garbage, and you will not be able to produce decent results from it, right? So this is the first type of the metrics. As the second type of the metric, that actually goes to what specifically we're trying to solve, what we're trying to reach. Are we trying to well, if it's image processing, are we trying to do specific set of the false positive, false negative results and stay within those limits? Are we trying to reduce number of the mistakes in, I don't know, in healthcare pair lookup algorithm or process? Are we trying, and you need to say, well, I mean, we want to have it within 99%, right? This error, or number of errors during the patient appointment scheduling 99.9% should be done properly, and so on, so on. Because if you don't define those metrics, you can actually run into two opposite problems, and that's actually very funny. Well, I mean, not funny. That's actually not funny when I saw it in the practice. The first problem, we just machine learning or LLM model works. Look, we just feed the data and it produces the results. You take it to the production environment and it kind of works, it kind of produces, but to be frank, manual process was more reliable, but okay, it works, right? I mean, it does something. So this is the case when the model just doesn't produce too good result. And there is opposite, and I'm not sure which one is worse. So like, no, this model doesn't work because it produces good results only in 99.999%. We do need to improve to close this 1,000% cases. Like, no, you don't. It's fine. It's okay because manual process produces 10% of the error during this process. Even if it would be 95% success, that would be already a success rate. It reduces the number of error to twice. Guys, what are you doing? I mean, we cannot just keep improving it. We need to release it, and it's not an engineering issue because just nobody set them this metric, a threshold of the success for their model. And it's if you don't define it, they will just come up with their own understanding, and their own understanding doesn't meet business requirement at all. They sometimes don't understand, don't know it, and it's okay because their goal is to create this model. They know very well how to do this model, right? But this number is just taken somewhere from the sky and just used randomly. So defining those metrics and actually clarifying it for the engineering model for AI team, very useful, and not just very useful, no, I will correct myself, is an essential piece for the successful project.
Yeah, I think also there's times that we want the machine to do so much. We expect it to do so much more than the human can even do, because are we actually assessing the manual process as well as we are assessing the actual machine or the AI process? I want maybe just touch on some of the other metrics I was thinking on. So making sure your metrics align with your business goals. So making sure that that's in place. So does it have a revenue impact? Does it have the longer term strategic kind of things? And then the other metric that I'm finding very interesting, and I'm seeing a lot more pushback than I initially initially thought, and that's user engagement. It's one thing to say here is a system, but are the people that are asked to use it, let's say those users we're trying to improve the output, the fear that they're going to have, that uncertainty, is this machine actually going to do better than me? Now I'm going to look terrible. Or how do I engage with that output, and what do I do next? Let's assume the company has a strategy of making their workforce more productive by removing manual tasks. But are they thinking about the hidden productivity improvement they're looking for? So let's assume you're saving 2 hours a day for a particular person by getting an AI to do a particular function. Have you thought through, from a metric point of view, what are you going to get that person to do those 2 hours now that they saved? As a very simple example. And are we getting the user to engage that, or are they just now filling their day with other busy work that may or may not really give us the productivity output? So what kind of metric are we saying? How do we value the user engagement, user productivity increase? And then there's another bunch of other metrics, things like the precision, like you said, and even understanding that we need multiple metrics to understand whether we're getting a result that we want or not. So there are probably certain metrics that are weighted higher. Let's say they got a higher weighting than other metrics, and that needs to be decided at the strategic level, at the business level. And that's why metrics aligning with business goals and outcomes is pretty critical. So yeah, for me, that pretty much is quite a challenge, I think, and that would increase uncertainty. But as you mentioned, I mean, human oversight and interpretability is, are we able to assess, is there an improvement? And are we interpreting those results well? Because you said, I mean, a 99.999 is probably 10% better than the manual output in any case. But yeah, shall we jump onto strategy 5? So strategy 5 is the human oversight and this interpretability, because I want to go delve into that a little bit more, because that links to all the other things we've spoken about. But let's go into a little bit more, because AI, we know, is not infallible. It's, I mean, keeping humans in the loop is crucial, I think, for reducing that uncertainty. Humans being part of that iterative process, and also part of the output and what they're going to be using it for.
Well, that's actually very funny that you said that keep humans in the loop. So let's actually again step back and kind of say what specifically we're talking about here. One of the misconception about artificial intelligence, well, it's not misconceptions, kind of mix it. It is true and false at the same moment, when we'll explain why in this podcast. So machine learning models, in most, especially with the old classical approach, they produce the results which humans cannot explain why those results were produced. So it just does it. So like, for example, image processing, it just marks those artifacts with a specific nodes because it does. Why it does? Because it was trained this way. We understand it, that it was trained this way. But when we train a radiologist to identify marks, you approach the radiologist and he say, well, you see, if this is a discoloration and this is a size and this is a this and this is a that, that would be this, right? So he can clearly explain why he made this decision. In regular, I guess, standard way or old way, in machine learning, you just cannot do this. It just produces this result. And well, this side effect of the machine learning, it produces two issues. So, well, the first of all, it makes people uncomfortable in general, right? I mean, what if it makes mistakes? Why it did this? I don't trust it because it just produces, and maybe there is a better solution, better result, and so on, so on. The second one, in some critical decision-making system, you got to have this information about why specifically this decision was made. Right, and unfortunately, you cannot have this explanation all the time. But we will go through, I guess, we'll go through the reducing uncertainty in this aspect and go piece by piece. So one of the approaches, and it's literally called HITL, human in the loop approach. So just like you said before, and what it does, it's actually it puts a human as a key decision point in machine learning, for example, system, right? So it would actually validate what artificial system produces, and especially if it's a high stake decision. And it doesn't have to be every single time, but it could be, well, again, depending on the process, statistical research and everything else, every 10th time, every 20th time, and so on, or maybe actually every time that it produces. And artificial intelligence is serves as an assistant actually for the human to verify his key decision. So you can actually put it other way around. And again, that is where it's very critical to make the right decision, and human expert can actually work on this. I mean, another side effect of this approach, by the way, and it's reviewing of the model and improving model performance over the time. So that's actually, to some extent, should be used in every model to some extent, right?
So isn't that's in part of the design? Because what we're trying to do is maintain human oversight and strive for that interpretability, but we need to make it easy, at least in the development of the AI, to have these points that human can interpret what the data is. I mean, there's one thing to look at a massive spreadsheet and say, oh, well, does that look okay or not? I mean, how are you going to know?
Right, but you just need to be careful and distinguish actually validation and verification of the model, which you can use some test data, and looking at test data actually matches what the data this model produces, and so on. And actually, if there is a deviation, human expert would explain that in this deviation, actually it produces proper results, so on. And actual decision making for the high stake decision. So they are to some extent similarly, and actually the processes involved are to some extent similar. The main difference where exactly you inject humans. Are you injecting humans into some model review processes, which goes, as I said, weekly, monthly, quarterly, annually, or you put him on the daily basis and you just do not allow the system to make the final decision without human signing on this decision? I mean, that he does review it and he say, yes, it makes sense, and so on. So it's just similar, but different applications, I guess.
I like that. Okay. I like that a lot. So I think we've covered the 5 main strategies. So
no, hold on, no, wait a second. We didn't get into the most interesting part. So remember, I said about that maintain human oversight and interpretability. So as a matter of fact, there is a technique which is called XAI, I believe. It's called explainable AI. So what it does, it's actually use so-called interpretable model. It's not always possible, but it can be used. There are specific models that are interpretable. And this model actually can produce a model agnostic explanation what specifically and why specifically it does. It's not a very common technique, and it's a very complicated technique to some extension. But if explanation is critical for the business purpose and it makes sense to invest in this direction, those approaches, they do exist, and people can actually, for the sake of their peaceful sleep, to receive those explanations that, hey, this model made this decision because of this or because of that. So and there are a couple more solutions. I mean, we're not going to get into the technical details, but my point is, and remember, like at the early podcast, we were talking about that industry is moving fast and industry is looking at the current problems, and one of the problems was unexplainable decision of the artificial intelligence model. So we're getting more and more useful, human-friendly solutions, reducing those pains that we have with artificial intelligence, and that's actually going to be even more involved with more useful and more user-friendly over the time.
That's really good bonus content. I mean, you surprised me with that because I wasn't expecting that. So just repeat, what is it called again? Just to
explainable AI technique, abbreviation XAI.
Oh, okay. That's that's fascinating because that
and
makes
another
a lot of
variation,
sense.
if you want to look, it's a LIME, local interpretable model agnostic explanation, or there is another one. I think it's a SHEP. sharply additive explanation. There is also this piece. So it's as I said, I mean, that these things do exist. You just need to know about them. And we're talking about, you see, even like even you know a lot about artificial intelligence, but I learned about those pieces only recently. And this is the area where, and remember when we were talking about, we don't know what we don't know, right? Because I mean, it would be, ML works like this. It's a magic. We don't know how it works. We don't know how to produce result, and we just take it as a true factor without even questioning this. Nope, apparently that's not complete true. You can work around this.
That really is. It actually rounds off the podcast well, because there's uncertainty, but there are now becoming tools available, becoming available that can help you overcome a lot of the uncertainty that you think you had. And maybe that's part of the education process, is to start thinking, maybe there's a tool already out there for something that could potentially be a worrying thing, but it shouldn't really worry you because there's already something out there to deal with it. So that was a really good point there.
Okay, well, I was happy to share something we learned.
No, that's excellent. I'm glad that you said that. I'm going to go look it up now immediately after the episode. So shall we sum up? So we got the 5 powerful strategies we just covered. So we had the clear problem definition that we went through in quite a lot of detail. We have the high quality representative data. So it's making sure your data is correct. You don't have gaps. You don't have outliers. You normalizing your data, etc. You got the iterative development and testing. So it's test regularly. Make sure that you keep seeing what the output is, so that it's cheaper. You're not developing everything and then checking it much later. And then we also spoke about sort of robust evaluation metrics. So the metrics aligning with the business goals, but also metrics to understand user engagement, metrics to understand financial and revenue impact, and metrics all the way down into what it is we're trying to deliver. So, and you mentioned, and every time you say that in our different podcasts, it gets me again, because the human, we think we do better than we actually do. But we don't, and we actually have a large error rate. And I think even just looking at the number of motor car accidents, in collisions on the roads, humans make mistakes, and I'm willing to even say that AI can potentially drive better than us humans, but we still think
it is better. It is better, but we still don't trust it. How is it happening?
So we that's the sort of the user engagement part of it, and then I like your the human in the loop, your acronym. You said human in the loop, HITL. That's great. Human oversight, and then interpretability. Having those tools available, I think that was really enlightening for me. Was to know that there are tools available to help you check why there's a certain result, so you can go back and understand why there's a certain output. That's stunning. I mean, so implementing these strategies, I think, it won't eliminate the uncertainty, but it can definitely deal with how do we use AI better, and understanding that we're not just dealing with AI, we're dealing with workflows, we're dealing with automations of manual processes a lot of the time. And now we're also calling on different data points that in the past, we just didn't have the capability to call on structured and unstructured data, which we're going to probably cover at some future podcast. But really to try and understand that there's a loads of information and data that you're probably not using. And the reason you're not using is it's maybe just too much, or you just don't know how to access it and bring it together into a place to make it useful. So just any final thoughts on our discussion today, Dimitri?
No, I think we covered some new techniques. We covered some top approaches to reduce uncertainty in artificial intelligence projects. Let's keep it as is, and looking forward to the next podcast. Maybe we will touch those explainable techniques a little bit deeper. sometimes in the future.
Because I think that's probably something that's relatively new for a lot of people. I mean, you definitely, by raising that, got my ears up, and I'm going to have to go and look that up. Okay. So I'm hoping everyone found this podcast useful, and really, please don't forget, please subscribe, leave a review, give us a few comments in the descriptions and that below. Have a look at the descriptions. There are a few links that you go and you subscribe to our newsletter, go to our website, go and have a look, and more importantly, engage us in a conversation. Pop that button that clearly says speak to an expert. We're quite willing to be open and direct and transparent in terms of things that even we learning on a day-to-day basis, and we know that things are changing rapidly as we go. But keep innovating, keep learning. And remember, the world of AI really is one of exploration, and there's a lot more certainty than you think, but there's always more to discover. So thank you very much for joining. Thanks, Dimitri, again, and we'll see you on our next episode.
Thank you, Dudley.